Algebra 2 Honors 9.3 Day 2 Notes. And I broke this up. There's not that many problems for this assignment, but that's why you have assignments due back to back. But I do want you doing these problems the way I am instructing you in these examples. You're going to have to draw a triangle. The triangles that you're going to be using are going to be one of these two, where the hypotenuse is 2 or root 2, according to what reference angle you're using. And so we are not going to be on a unit circle. So we are going to be using the definitions of trig functions, where sine of theta is y over r, cosine of theta is x over r, tangent of theta is y over x. And then we have the reciprocal functions. So we have cosecant theta is r over y, secant theta is r over x, and cotangent of theta is x over y once we get these set up. And so evaluate these without a calculator. You need to know how to do these without a calculator. And eventually we're going to go to what's called a unit circle, but not right now. I want these set up using these triangles where the hypotenuse is not 1. You must include a diagram. You have to show work. All right, so what you're going to do is you are going to need to figure out the reference angle. And so that's related to part of our homework, last part of the homework in 9.3 Day 1. And so draw a picture, and we're working with 4 pi thirds. So draw it in standard position. And so you need to think, well, 4 pi thirds is 3 pi thirds plus an additional pi thirds. And remember, when you divide it in thirds, it's really 60 degrees. You're 60 degrees beyond a half a turn. So you're going to be in quadrant 4. And so initial side, turn, and then think you're going to be going 60 degrees beyond half a turn. And so that's my reference angle. Right here is your pi thirds. So my reference angle, which I guess we can use the notation for, it'll be shorter, is going to be pi thirds. And so pi thirds is your 60 degrees. So that means we are going to draw this triangle, and we just have to get it oriented correctly. That pi thirds is your larger angle, so opposite it is root 3. The short leg is going to be the value of 1, and the hypotenuse is 2. And then we're going to make 1 negative and root 3 negative because we're in quadrant 3. And so this ordered pair is negative 1, negative root 3. We have an x value is negative 1, the y value is negative root 3, and the radius length is 2. So tangent is defined to be y over x. So in this case, that's going to be a negative root 3 over a negative 1, and the tangent of this is going to be root 3. The tangent is going to be root 3. You can even use it where tangent of this angle is opposite over adjacent. And that's going to get you your y over your x. Let's try it with cosine of 120 degrees. So 120 degrees, it's short of 180. It's 2 sets of 60. And so I should know where 120 ends up. Approximately right here, that's that 30 degrees beyond 90. And so that's that 120 degrees. But what we're going to do is drop an altitude, and we're going to look at what is the reference angle. And the reference angle is this angle right here, which is that 60 degrees. So when it's that 60 degrees, again, we're going to use this first triangle, and opposite the 60 degrees is that long leg. Adjacent to it is your short leg of 1 and your hypotenuse of 2. I want to see those values, and then the x value will be negative. Y would be positive, and the hypotenuse will always be positive. It's your radius. So we have x is negative 1, y is root 3, and your radius, which is your hypotenuse, is 2. So cosine is x over r. So it is going to be a negative 1 over 2, and that is your cosine of 120 degrees, negative 1/2. Again, I could come here and go, okay, here's my triangle, this is 60. Cosine is adjacent over hypotenuse, so I get negative 1 over 2 that way. Cosecant, negative pi force. Well, you're going to be rotating clockwise, and pi force is when you take a half a turn and divide it into force. That's equivalent to 45 degrees. So we're going to be going like this. This is your reference angle is always considered to be positive though. So my reference angle is pi force, even though we rotated clockwise. The angle is negative, but in terms of the reference angle on the triangle, we're thinking of that as pi force. But so now that is your 45, 45, 90. So you are going to be using this other triangle where this is 45, 45, 90. And on this, the legs are going to be 1 and the hypotenuse is going to be root 2. So I kind of like those when they're 45. So this is 1, and the hypotenuse is root 2. But we're going right 1, we are going down 1, so the y value is negative. So I have an x value of 1, a y value of negative 1, and the radius here is root 2. Cosecant is the reciprocal of sine, so it is going to be your radius over y. It's your hypotenuse over the opposite. So your radius is root 2 and your y value is negative 1, so it ends up being negative root 2. Again, when you've got this triangle drawn and you know this is your angle and you know the definition of cosecant as hypotenuse over opposite, you can figure out it's root 2 over negative 1 that way as well. Cotangent of a negative 210 degrees. Well, I'm thinking a negative 210 is a negative 180 and an additional 30 degrees beyond that. So I'm rotating clockwise. I'm going to end up in quadrant 2. Rotate around, but I'm only going to be 30 degrees beyond that half a turn. And so that's going to create this reference angle to be 30 degrees. So stop somewhere on that terminal side, drop perpendicular to the x-axis, and then we're going to be using the 30, 60, 90. And so hopefully you're getting that down, but above the hypotenuse is going to be 2. Opposite the 30 is the short leg, so the y value will be 1. And the long leg is going to be negative root 3. And so that means my x value is negative root 3, my y value is 1, and my radius is 2. Cotangent is x over y. So I'm going to get a negative root 3 over 1, so the value of the cotangent of negative 210 degrees is negative root 3. Again, you've got this triangle set up. This is your 30 degrees. That's your reference angle. And cotangent is adjacent over opposite, negative root 3 over 1, getting negative root 3. All right, cosine of 10 pi force. What you want, it's more than a full rotation. if you're in pi fourths, I can think of 10 pi fourths as 8 pi fourths plus an additional 2 pi fourths. And so this is your 10 pi fourths. And that means I'm at 2 pi plus a pi halves. Okay, well, I said we were using 30, 60, 90, 45, 45, 90s, but I forgot they will throw in perhaps a quadrantal angle, and you have to remember that from day one notes. I forgot that they might throw some of those in there. All right, so we have 2 pi plus pi halves. So if I go to graph this, initial side, a full rotation, and we end up the terminal side on one of the axes. And when that's the case, that is when that quadrantal angle, you have to change up that method of how we do that. And that's where we are going to consider we are on the unit circle. And we're going to figure out, okay, if we're on the unit circle, this point's going to be 0, 1. So x is going to be 0, y is going to be 1, and the radius is always a positive 1 on that. And we're going to use that unit circle when we have a quadrantal angle, when there are a multiple of 90. And so cosine is just the x value when you're on the unit circle. You can do x over r because it won't affect anything. The radius is 1. But it's nice to know that it is just that x value, and so it is going to be 0. So the cosine of 10 pi fourths is 0. For secant, we have a negative 17 pi 6. Well, a negative 17 pi 6, I got to figure out where is that going to fall. And I know I'd have a negative 12 pi 6 would be a negative 2 pi. And I would need an additional negative 5 pi 6 to get to negative 17. So that's a negative 2 pi, a full rotation clockwise, and an additional negative 5 pi 6. So that's going to end up in quadrant 3. You're going to have your initial side, you're going to rotate clockwise, a full rotation, and a negative 5 pi 6 is 1 pi 6 short of a half a turn. So pick a point on there, draw a triangle, and so that reference angle right here is pi 6. My theta prime is pi 6. That's that 30 degrees. So use your 30-60 triangle where the hypotenuse is 2, opposite that short leg, that 30 degrees is 1, and the long leg is root 3. But we're in quadrant 3, so it's going to be a negative x and a negative y. So x is a negative root 3, y is a negative 1, and the radius is always going to be considered positive. And secant is the reciprocal of cosine. It is hypotenuse over adjacent. It is y over x. And so we are going to get a negative 1 over a negative root 3. And so that is a positive 1 over root 3, and you rationalize. So it's root 3 over 3. Root 3 over 3. Or, excuse me, I gotta go back up. I did x over y. That's terrible. So sorry. I don't know what I was thinking. Okay, so I said secant is the reciprocal of cosine, which is your hypotenuse over your adjacent then, which is your r over your x. And so my radius is 2, and my x value is a negative root 3. And then you're going to need to rationalize by multiplying by root 3 over root 3, and you're going to get a negative 2 root 3 over 3. That's better. So, have a couple of you try them. So I suggest you pause the video and then you give it a shot to finish those up and see how you do. Oh, your answer to the first should be a negative 1/2, and the answer to the second one should be a negative 1. Let's see how those worked out. 11 pi 6 is an angle that we want you to just know it's 1 pi 6 short of a full rotation. And so it's going to look something like this. That reference angle is going to be pi 6. So pick a point on the terminal side, draw a triangle, and that should be to the right √3, down 1, and the radius is 2, if you set it up correctly. And so sine is your y over your r. And in this case, x is √3, y is -1, and your radius is 2, and you get a -1 over 2, which is your -1/2. For the tangent of a -585 degrees, I want to think, okay, -585, if I subtract 360 from a positive, it's 135, or no, 225 degrees more. So -585 is going to be a -360 plus a -225 degrees. And so when I'm going to rotating clockwise, 225 is going to end up in quadrant 2. So start positive here, go a full rotation, and 225, this is 180 plus 45, where they're both negative. So we're going to go half a turn and then 45 degrees beyond it. So we end up with a 45-degree reference angle. So we're going to go to the 45, 45, 90 triangle. And on that, the legs are both 1 and 1. And for the radius, we use √2. But we're going left 1, so we'll make that negative. And now the tangent is y over x. Tangent is y over x. And so the tangent of a -585 degrees is going to be, my y value is 1, my x value is -1, and it's going to be -1. So there's not a lot of problems, but I want that done on every single problem where you draw the triangle, try to make a 30 look more like a 30, and a 60 to look more like a 60, and a 45 to be looking like a 45. It can help you as you set up the triangles. Now, the signs, S-I-G-N-S, pluses and minuses of the 6 trig functions, I want you to think about the values. We have a summary at this in the very bottom that you want to know, but you really want to just know how they are developed. And I said that the radius is always going to be positive. That's just a fancy way of saying r will always be positive. So it really has to do with the quadrants. In quadrant 1, x and y is positive. And since x is positive, y is positive, and r is positive, they are all positive. All 6 trig functions will always be positive when the terminal side ends up in quadrant 1. When the terminal side ends up in quadrant 2, however, since x is negative, but yet y is positive, and of course the radius is always positive, I'm going to look at things that deal with x. And if there's an x in there, it's going to be negative. If it just has y and the radius, it's going to be positive. Excuse me. And so anyway, so that y is positive and the radius is positive, so sine's positive, and therefore cosecant is. Those are the only 2 that are positive in quadrant 2. The cosine, secant, tangent, cotangent all have an x in them and are used with another value that is positive, so they end up being negative. And in quadrant 3, both x and y are negative, so you got to be kind of careful. Since y is negative but radius is positive, sine's negative, and the reciprocal will be negative. Cosine x is negative, but the radius is positive, so negative divided by positive is negative. And secant's the reciprocal, so it's negative, but tangent deals with both a y and an x, and you get a negative divided by a negative, comes out positive. And cotangent is x over y, they're both negative, so tangent and cotangent are the only two things positive in quadrant 3. And in quadrant 4, you're to the right one, or your x values are positive, excuse me, and your y values are negative. And so in quadrant 4, anything that deals with x and a radius is going to be positive. And so that's cosine's positive and secant's positive. Anything that deals with y and y with a radius is going to be negative. So sine and cosecant are going to be negative. And tangent deals with y and x. One's negative, one's positive, so they end up negative. And so we have this little saying, and it has to do with all are positive in quadrant 1. And then we kind of focus on sine, tangent, and cosine. And we say all students take calculus. And the idea is all are positive in quadrant 1. Student starts with an S, so sine, and then of course its reciprocal function are the two that are positive. The other four are negative in quadrant 2. T for take, all students take. T is tangent, so tangent and cotangent are what are positive in quadrant 3. The rest are negative. Calculus, the C for calculus is cosine, and cosine, and then therefore its reciprocal function, are positive in quadrant 4. You're going to want to make sure that you get these SIGNSs correct. And so hopefully you know how to get them the correct sign just by using the definitions, but here's another little thing to use to memorize them.